Hello everyone, I'm Kirti Mettu. I'm a master's student from Computer Science Department in University of Regina. I'm going to talk about medical advancements using 5G and cloud technologies. Here is the overview of this presentation. First, I'm going to talk about the introduction and some of the important terminology used in computer science related to medical field, some of the healthcare models, the role of prediction, intermediate tools, and two main architectures like OCC e-health system and O-health communication system, their benefits, challenges, and finally the conclusion. There are multiple branches in engineering and science to benefit the humans in health and comfort. And over the years, medical field has been constantly evolving from the traditional applications and equipment. With the rapid development of science, medical treatments has become one of the focuses for everyone. There were problems encountered in the traditional models, and since the recent times, seeing a doctor has become such a difficult situation, both in terms of availability and price of expensive treatments. However, with the formal introduction of the concepts of cloud computing, networking, and Internet of Things, this field has been advancing and creating solutions every day. So, the main goals of latest advancements are like remote consultation, operation guidance, and first aid services. Alongside the patient's health monitoring, there is a need to ensure the overall quality of care and quality of privacy of the patient. In order to dig deeper in the medical advancements, we need to know these following terms. Firstly, IOMT. The Internet of Medical Things is an amalgamation of medical devices and applications that are connected to healthcare information systems using networking technologies. The IOMT serves all aspects of the medical field, including identity recognition, vital signs monitoring, remote monitoring, medical drug waste and equipment monitoring. WSN is abbreviated for Wireless Sensor Network. It can be defined as a network of small embedded devices called sensors which communicate wirelessly following an ad hoc configuration. Nowadays, sensors have been widely used in the operation rooms, emergency room, and intensive care unit to monitor and display the main conditions of patients. Raspberry Pi, Arduino, and Node MCU are the microcontrollers, which are dedicated devices that connect with other devices. They contain one or more processor cores along with memory and programmable input output peripherals. They have open source software and framework for data processing or transmission. In the monitoring systems, temperature and pulse sensors are mainly used to track the patient's health. W-band are the wearables and wireless body area networks that are seamlessly connected to the internet and pave a way for the enhanced services. Cloud computing is defined as an on demand availability of computer system resources, especially like data storage, computing power, without the direct active management by the user. It is generally referred to data centers available to many users over the internet. Apart from the sophisticated hospital environment, here are some of the economical and existing models for patients' health monitoring purposes. K-Healthcare model. This model consists of Arduino development boards and Raspberry Pi along with pulse oximetry sensors. Here, all the sensor information travels to the cloud and then to the end user output devices after some processing. To support remote monitoring, smartphones are also used. The following are some of the models where different monitoring sensors and microcontrollers are connected to the cloud platform to transmit data and receive information on processing. In some of the models, predictions are also included to guide the doctors. The prediction systems would go inefficient if it invokes the traditional AI approaches like fuzzy logic. As discussed earlier, here is the basic flowchart model of a health monitoring system. Initially, the sensors are responsible for retrieving the vital data readings and transmit to the local node MCU. It can act as a Wi-Fi or any network technology module to connect all the sensor data and do basic processing and transmit it to the cloud. Cloud is a data center to store data, helps to perform high-level computations, check for any abnormalities, and transmit the live information to the end user devices or phones. Based on the current status, possible suggestions are also made by the system. How does a prediction system works? This includes concepts of machine learning, deep learning, and many subtopics. But on a higher level, let's understand through these steps. We need to create a huge database which has maximum inclusion of types of patients' diseases, their symptoms, and all its cures. A machine learning model has to be selected to which the data is fitting, and it has to undergo processes like training and testing. On doing rigorous training, the model outputs has to be made sure that it is the best fit by verifying the accuracies. A confidence meter along with predictions must be displayed about the next possible actions or any first aid measures by displaying some confidence percentage values. Apart from the main cloud application, these are some of the intermediate tools that are to be taken care of. Firstly, we have power units. If the sensors are wireless, then regular intervals has to be made to uh, charge them, and if they are wired, we have to do some casual checks so that to find any power abruptions. These are two example wired sensors. Firstly, DS18B20 is a temperature sensor, and AD8232 is a sensor used to calculate the electrical and muscular functions of the heart. In some systems, microcontrollers are used as complementary devices just to make simple network connections and unlock to digital transformations. They can have external units for memory and local data storages as well. A cluster head is a high bandwidth sensing node that is used to perform data fusion and data aggregation functions in the wireless sensor network. Based on the system requirements and application, there'll be more than one cluster head. Next, we have online data storage. Here, Firebase is a simple and user friendly real time database environment. It is meant to store and provide quick information to the users who are connected to it, and they receive updates on every change. It works on different cross platform applications for iOS and Android, etc. Uh, Finally, we need a web or mobile application to see the information for which Flutter framework can be used. Flutter Flutter framework is based with Dart language, which is capable to support both Android and iOS platforms, and it helps in the easy customizations to the user required dashboards. This is how the layers of cloud computing are classified. The bottommost is the edge layer, followed by the fog layer and the cloud layer on the top. The edge layer is connected with the end user devices through the edge gateway. As for edge computing, the data is processed on the device or sensor itself without being transferred anywhere. With fog computing, the data is processed within the fog node or the IoT gateway, which is situated within the lab. It is also known as extended computing to the edge of the network. Another main difference is that in the edge, the data storage is centralized, whereas in fog, it is decentralized. The top layer is the cloud, where the data actually resides, and it is further used by multiple servers. It is generally used for higher computations and scalable dependent applications. OCC based e health solutions. OCC is abbreviated for optical camera communications. The OCC systems is used to receive the monitored data from the wearable sensors or patches and its framework is included in the 5G e-health architecture. The 5G capabilities for e-health solutions are considered as below. Firstly, OCC, and then a subsystem of optical wireless communications, that is OWC, and then the transmitter or LED arrays, then a camera, and lastly a receiver or image sensor. Based on the quality of service, the applications of OCC are categorized into the following. They are remote control applications, real-time critical applications, and real-time non-critical applications. This is the basic architecture of the proposed OCC-based e-health monitoring systems. The bottommost section of this diagram is a data transformation block. Here, the skin patch sensor is used for sensing the body condition and observe various medical parameters. The transducer converts these medical parameters to electrical signals. Further, ADC converts this data into from analog to digital signals. The encoder provides the encoded form of digital data and which is further modulated by the modulator. Finally, the LED arrays transmit the digital signals through the optical frequency band. The camera has multiple functionalities including ultra high definition video capture, emotion detection, and OCC. Here, the video system is optional because of the privacy issue, but if it is not concerned, then it can be turned on. The camera uses multiple interfaces like 5G and VLC to make wireless connectivity with the backhaul network. The OCC systems can also be connected via wired networks. The biggest advantage of this system is that, along with patient's vital information, the video or picture capturing is helping in detailed view of the patient condition, same as that of the monitoring of a patient in live. In advanced systems, the entire subsystem under this optical channel and camera can be replaced by a robot and transmit data directly to the core network. Thus, based on the application, the other types include robot assisted systems, multiple patients monitoring, and remote patient monitoring. In some cases, the patient only requires suggestions on quick health fixes or some precautionary measures. Such information can be provided through the combination of using smartphone based app, fog or edge computing, and mobile communication. OHealth is the short form for opportunistic health. The opportunistic healthcare is the new smart healthcare paradigm and provide its architecture in the context of fog, edge, and cloud computing. It is mainly designed for the purpose of time conservation and better utilization of commute time for the patients traveling to hospitals from greater distances. Here, W-band devices and mobile phones are the key resources to provide the data collected from sensors to the fog nodes of cloud. As fog level of computing can help in doing simple processings and record fetching operations from the central cloud, an initial questionnaire session and surveys can be taken beforehand so that by the time the patient reaches the doctor, there will be a detailed view of the problem statement from the patient to the doctor. In the most probable healthcare problems, these systems are capable of giving common cure predictions and suggestions to the doctors. This is the architecture of Edge Cloud IOMT. The Edge Cloud IOMT consists of three layers called terminal layer, edge computing layer, and cloud computing layer. The terminal layer is the closest layer to the end user, which is mainly responsible for collecting data from the local devices and uploading the data to the edge. This can reduce request delay and effectively avoid data leakage caused by long distance transmission and other security issues, which is critical for extremely sensitive medical data. The cloud layer here is powerful data processing center with massive computing, storage, and network resources that can summarize, analyze, and permanently store the data uploaded by the edge computing layer. The cloud computing focuses on the overall grasp while edge computing focuses on the local. The rational use of edge cloud collaboration will better promote the development of medical application scenarios. So, to use the advantages of edge computing, there has to be a data center or cloud computing in their architecture. With the implementation of previously mentioned architectures and systems of remote monitoring, the biggest benefits are the time conservation and efficient use of resources in a hospital. Alongside those benefits, there are also reduced medical expenses, helping the underprivileged sector, the ability to serve more people by the doctor, and guaranteed quality of care. Remote serving is highly advantageous in the cases which needs least physical examination, where the cure can be identified more likely through the image visuals of the patient. However, every system strives to achieve maximum efficiency. There will always be certain challenges upcoming in a way or other. When the doctors are located in different parts of the world and the patient information and cloud resources has to be made available globally, this could bring up difficulties or dependencies in the system like intermediate component errors. Also, it includes constant monitoring and maintenance of sensor devices. Suppose if there is any failure, these has to be replaced at regular intervals. Resource sharing is still a problem for sophisticated treatments, which include greater equipment. Also, the system would fail in giving good accuracies for the predictions of rare diseases. And alongside constant enhancements in the system, the doctor's team should also be thorough with the system changes and updates happening. And finally, the standardization of the updated models is very important. This process would become slow if there are numerous updates and workarounds happening to a system. On understanding the different models and architectures, I came up with this conclusion. Firstly, there is always need for regular optimizations for customized softwares provided they have sufficient backup plans for every upgradation. Secondly, constant monitoring is required to improve efficiency and predictions accuracies in the system. So, on a whole, it is understood that this field has growing opportunities for research and development with the medical evolutions and changes happening every day. These are all the references and research publications that help me in my knowledge and understanding. Thank you so much for listening.